Hello everyone, my name is Aniket and in this video I will going to explain Fourier series. The motivation behind this video is not only understand the concept but also visualize the Fourier series. So let's get started. So I will start with the definition. A Fourier series represent a periodic function as an infinite sum of sine and cosine terms. So what is the meaning of this? So using Fourier series, we can represent any periodic function in terms of sine and cosine terms. Okay. So Fourier series of a function f of x is given by a naught by 2 plus summation of n is equal to 1 to infinite an cos of 2 pi nx divided by b minus a plus summation of n is equal to 1 to infinite bn sine of 2 pi nx divided by b minus a. So you can see here in this Fourier series expansion, cos and sine term is there. So you are representing this periodic function in terms of cos and sine using Fourier series expansion. So first of all, you have to calculate a naught value, an value and bn using the formulas. So these are the formulas of a naught, an and bn. Okay. So to understand the Fourier series, I will take one example of square wave function. So let's start. So let us take the example of square wave. So square wave is periodic and we consider the period of square wave is 2 pi. So after 2 pi, it repeat itself. Okay. So square wave function have positive 1 value when it is 0 to pi. So when it is 0 to pi, that square wave function have positive 1 value. When it is pi to 2 pi, this square wave function have negative 1 value. So when it is pi to 2 pi, this function have minus 1 value. And 1 minus 1, then again 1 minus 1. So it repeat itself after 2 pi interval of time. So after 2 pi, it repeat itself. So it is a periodic function with period 2 pi. Now, what we will do, we will find a Fourier expansion of this square wave. So, for this, we have to calculate a naught, an, and bn value. So, let's see that. Now, we will see calculation part of a naught, an, and bn. So, let's start with the a naught. Formula of a naught is 2 upon b minus a integration of f of x dx a to b. Here, a is start point of one period, b is end point of one period. We are calculating a naught for square wave. So in square wave is starting from 0 and square wave one period is end at 2 pi. So it is a is nothing but 0, here b is nothing but 2 pi. So if we put 2 pi here and 0, so we will get 2 upon 2 pi, then 2 get cancelled, then we will get this expression. Now we know that 0 to pi square wave have value positive 1 and then pi to 2 pi square wave have value negative 1. So we can split the integrals 0 to pi then pi to 2 pi. 0 to pi is 1 value, then pi to 2 pi minus 1 value. And if we solve this integration, we will get a naught equal to 0. Similarly, we can calculate an value. I will not go into the calculation part of an. If you calculate, you will get an is equal to 0 for all values of n. So similarly, we can calculate bn value, and if you solve these integrals, we finally get bn expression as this. So bn is equal to 2 upon pi n in bracket 1 minus minus 1 raised to n. Okay, if n is even, then you can see here if n is even, then minus 1 become 1 and 1 minus 1 will become 0. So bn will be 0. Similarly, if n is odd, then this minus 1 remains as minus 1, and 1 minus minus 1 will become 2. So Bn will become 4 upon pi n. So finally Bn is equal to 0 when n is even, and Bn is equal to 4 upon pi n when n is odd. Okay. So we already see that n is even. So if n is even, this minus 1 raised to n will become 1 and the bn will become 0. If n is odd, minus 1 raised to n become minus 1 and this bn term will become 4 upon n pi. So bn is equal to 0 when n is even, and bn is equal to 4 upon pi n when n is odd. Now we will put a naught value, an value and bn value here. A naught is 0, so this term will become 0. Then an is 0, then this term also becomes 0. And bn is bn is 0 for even terms, and bn is 4 upon n pi for odd terms. So bn only survive for odd terms. So final expression will become f of x is equal to summation of n is equal to 1, 3, 5 odd terms till infinity. Bn value is 4 upon n pi, and sine this is nothing but 2 pi. So 2 pi will get cancelled, nx. So final expression will become this. So you can see here we can represent a square wave function which is a periodic function in terms of sine. So we see that after putting the a naught, an and bn value, we will get Fourier expansion for square wave function as this. So in this expression you can substitute value of n. So 4 upon pi n is equal to 1 sine x, then 4 upon pi n is equal to 3 sine 3x, then next n is 5, 4 upon pi into 5 sine 5x, and so on. So if you take 4 by 5 common, you will get this expression. So finally we are representing square wave function in terms of infinite sum of sine. Now we will visualize the Fourier series for square wave function using the graphs. So you can see here I plotted the graph of f of x versus x, and this dotted line is square wave and the blue one is Fourier approximation. You can see here for this graph I only consider first term. Okay, now what we will do, we will add another term here and we will see the graphs. So let's see. So you can see here when we add two terms, we will get this Fourier approximation graph which is closer to the square wave as compared to the first case. Okay, now we will add three terms. Let's see what will happen. For this graph I added the three terms, and you can see here this Fourier approximation is closer to the square wave as compared to the when there was only two terms. Okay, now we will add more terms. So you can see here for four terms the graph is even more closer. So for five terms the Fourier approximation is even more close to the square wave. So you can see here as we adding more sine terms, the Fourier approximation get closer to the square wave. Okay, let's see for next when there is a six terms. Then this is for when there is a seven terms. Then this is when it is eight terms. Okay, we will get this graph when n value is still 25. So f of x is like that, f of x is equal to 4 upon n, here 4 upon pi sine x, and last term will be 4 upon 25 pi sine 25x. Okay, so for this expression we will get this graph. So we will get this graph when n is still 45. So the expression is like 4 upon 45 pi sine 45x. Okay, so this is when n is still 75. This is when n is still 105. So you can see here, as we increase the number of terms, the Fourier approximation get closer to the square wave. So thank you for watching this video.